Okay, so next one, we've got another acceleration question. So I thought it'd be useful to just come onto the side here to just say, right, you're going to have to be comfortable in finding v squared minus u squared equals 2ax. That's two speeds and a distance. You've got to be happy with a equals v minus u over t. That's two speeds and a time. Or the other one is we can work out acceleration using forces. This is Newton's second law of motion. So I'll put N2L. And for that, I've taught you my fat auntie, which is what this next thing is. The next question is going to look at. So just be super careful though. We've got all these accelerations, and it's why the exam board love using it. And it's just, can you pick the right question? So now I'm just going to summarize this. I've got a force. So instantly I'm circling that F. Okay, I get it. And it's, well, what formula do I have? I've got ton, this is mass. So I can see I've got an M and F and A. So my fat auntie, I've got to change tons into kilograms. So times 1,000 equals 2,000 kilograms. And now we're away. Except for, that needs changing as well. Mega times a million. I hope that's a million. Yes, it is. So now we're ready to go. First part formula, we're after A. I can see the F's over the M. So A equals F divided by M. Next part, put your values in with you convert into the SI units. So 0.56 times a million is 560,000 divided by 2,000. Put that into my calculator. And I get my answer, 280. And probably the most important unit, meters per second squared. Okay, next part, what's the inertial mass? This is just this. So Newton's second law is this basic idea that his first law is the law of inertia. Objects that are moving want to keep moving. Objects that are stationary want to stay still. But he said a little bit more than that. So in his second law, he said, well, we can do some maths on that to actually sort out how do things accelerate. So the inertial mass is the ratio of force to mass to start an object moving. And what's lovely is we can look at this my fat auntie triangle in terms of what's it saying. It's saying for an object to accelerate, I need to look at the ratio of the force to mass. If this isn't enough, the object can't move, it can't accelerate. But as soon as we get that, it'll start moving. A nice way to think about it is if I've got a car, I might need two people to get it going. But once it starts rolling and doing its thing, I might only need one person. Now I need less force. Why? Because this object, the car, now has some inertia. It wants to keep moving, so I don't need to apply the same force to keep it moving. So now we've got an example of, well, find the inertial mass then. So get my formula, my fat auntie. And the crucial part is anytime you see this word inertial mass, you know that you're dealing with Newton's second law. And really, it's linked to his first law as well. Let's change that to a 1. So we've got kilonewtons here, and please make sure you know how to do kilo. So times 1,000 equals 2,600 newtons, and it wants the inertial mass, M. M equals F over A. Take our force, 2,600, then divide by the acceleration, 2.5. What's tricky with all the physics things is it's just, can you pick the right equations to use? And remember, you'll have a formula sheet with most of them on. So 2,600 divided by 2.5 equals 1,040, and the units kilograms. Again, mark, mark, mark. And that's that done.